Machine learning is all the hotness these days, and ML.NET brings some of that machine learning goodness to Microsoft.NET applications. Let's mash on that. Hi everybody, and welcome to another episode of the Asp.NET Monsters. We're actually recording on location today in Regina, not to be confused with China, which is what my children think that I have been saying all week. We are at a conference. We're at Prairie DevCon, doing some presentations, and we've managed to get into the same room. So we're
going to see you in person.
A little bit of recording. Yeah. Even though we live in the same city, we live in like opposite ends of the city, so we never see each other because, in my mind, you live like a really long way away, even though it's probably only half an hour.
So instead, we fly to another city to see each other. At least we didn't fly all the way to China.
I'm kind of disappointed I'm not in China. Anyway, so I want to take you through just like a quick demo of some ML.NET. I think we'll probably do a few more episodes on some other ideas around ML.NET, but we'll start with this one here. So I am going to start up a brand new project here, and I'm going to add some machine learning stuff to it. So I'm just going to do a console application for the moment. We'll take a look at how to incorporate this into an ASP.NET application later, but we'll give this one a spin for now. All right, so this is just a brand new console application here, and I have installed a plugin here, an extension for Visual Studio, which adds some ML.NET stuff here. This is still in the preview, but it's really quick and easy to add this. So we'll just do add machine learning. If you don't want to use this, you can just add the ML.NET libraries yourself. But we'll go ahead and kind of run through this sort of sample way of building the application here. So I chose, I had a couple of options here for what sort of scenario that I have here. So I'm going to do sentiment analysis for this one. There are a lot of other fun scenarios here that we'll take a look at a little bit later here. So first of all, you need to train your model with some data. And this can be done ahead of time if your data is fairly static, or you can kind of continue to refine your model as you go forward. So we're going to choose a sample corpus here. So I have this, I think, fairly commonly used file from Wikipedia that contains some positive and some negative comments, and they've been manually classified into, well, positive and negative comments.
I've never heard of positive internet comments, Simon.
Yeah, it's pretty unusual. I think they have to search pretty hard for them. But once in a while you find them, so long as you avoid like Reddit and Hacker News and Facebook and Twitter basically everywhere. So the data that comes in, it's a tab-separated file, which is like a comma-separated file, except fatter, because tabs are like 8 times as big as a comma, or 4 times as big, depending on who you talk to. So it's got 2 columns, and it's got a sentiment and the text associated with it. So sentiment is just a 1 or a 0 as to whether it's positive or negative. And then we're just going to leave this one here. We only have 1 column to do our classification on, which is fine for this one here. So this gives you a preview of some of the stuff here. So we have a label here that's like 1 is a negative comment and 0 is a positive comment. I don't know if there's any more data here that we'll be able to find here. So here's some examples of negative comments and some examples of positive comments. So now that we have that, we can go and train the model. And in this case, we're going to train for about 10 seconds. It seems like a weird metric to use, but this is a very small sample size, so we should get relatively good results with that. So what it's going to do is it's going to divide up the data behind the scenes, and it's going to use some of it as a training set, and it's going to use some of it as a validation set. So we trained this model, and we got like 71% accuracy, which is not
great,
well, but we'll take it for now. We can see here that that's kind of the accuracy that we came up with, and we're going to go and hit code here. So hopefully this works properly, and I remember the right checkboxes when I started this project. When I hit add projects, it's going to add a couple of new projects to my solution. So it's added a model project here, and it's added a console app project here. So included in the model project is our actual model. So when you're distributing your application, you would distribute this mlmodel.zip as well as your application. You wouldn't drag it into other files. So it doesn't make any sense. Why would anybody do that? So now that we have this model, we can use that to kind of analyze our data set. So I happen to have on my clipboard the code that we want for this. So we can create a new model input here, which is pretty much just the same kind of CSV file style input that we had before. We're going to give it some sentiment text here. So in this case, we're going to put in a positive comment. You did a great job. And then we're going to go and consume the model. So we'll ask the model to predict an output for us. And the result that we get out of it is going to have two components to it. So it's going to have a prediction to it. So that's going to be either a true or a false, depending on if it's positive or negative. The way this one's been set up, I think that if it's a positive comment, it's going to come across as a false, because we're looking for negative comments in this case. And then we're going to have a score assigned to that. So the score gives you an idea of like how sure the model is that it has got the right value for this. So let's go and run this and see what we get.
So we would expect a 0 in this case. It looks like a positive.
Yeah, so we would expect like a false. Eventually, when it runs. Yeah, so there we go. So that was a positive sort of comment, and then we can give a negative comment here too.
What's the range on the score?
I don't know, actually. I think maybe it looks like it's positive and negative around 0. So this is a negative comment here, and I think it's fairly certain that it's a negative comment. I don't know if that's, yeah. I don't know what would happen if we gave it something that was a little bit more neutral. Of course, this is a fairly small corpus that we've trained this on, so let's see what we end up with on this. True. So that's negative, but maybe slightly less negative than the last one.
Mm-hmm.
An okay job. It's detected sarcasm.
That's impressive. So it's interesting how easy it is to use once you've trained that model. And you said the model training is something you can like retrain as you go.
Yeah. So it can be a little bit timely to do retraining. Right. The places that I have it deployed, I'll have like a button on the website that says retrain the model, but I'll kick that kind of off as a background process and then update people when it's done, as opposed to kind of stalling the pipeline to retrain the model within that.
That makes sense.
And then obviously, like depending on the size of data that you have, it's going to be a little bit more expensive to train it for longer.
But generally speaking, training a model is quite resource intensive and can take a long time.
Yeah, for sure.
But doing a prediction is fast.
Yeah, so that's the idea, is that if you're going to train a model, you're paying a lot of the price up front to do the model training, and then once you have built that model and you've saved it off into like a zip file or something, then that model is fairly quick to unzip and use in your predictions.
Very cool.
Yeah. So we'll take a look at some more practical applications for this and how to get into Asp.NET in a future episode.